Good morning to all. Myself Preeti from R&D Engineering College, Department of ECE. So today we will discuss about types of piezoelectric transducers. So types of piezoelectric transducers, we can tell n number of types are there. So we will discuss some of the types in the further slides. So the first one is piezoelectric semiconductor. So whenever we talk about semiconductor, a PN junction comes to our mind, right? So it is actually the characteristics of piezoelectric itself. It is anisotrophic. It means it will be very non-uniform, non-uniformly distributed. So this non-uniformly distribution and all will be seen under PN junction. So a very large reversible current change in the current across the junction will be obtained, and this phenomena is because of anisotropic stress effect. Anisotropic effect is nothing but a non-uniform effect. Okay. So the second one is piezoelectric force transducer. So piezoelectric, as it has been obtained from the Greek word piezo, which is nothing but press. So here we just keep the changes alone in your mind. So the force here going to be given as the pressed input. So it has a serial and parallel connected biforms. You can see these are the biforms, serially connected and parallelly connected, and these both join together. So there are two types of biforms, bender type biforms and a twisted type biforms. So a twisted type means it can be easily rotated for all the 360-degree. Okay, so there are two different types of biforms present. One is bender type and another one is a twister type. So this is going to be the bender type and this is the twisted type biforms. So piezoelectric strain transducer. Third one is piezoelectric strain. So again the same thing, the press which you are going to give in here is going to be the strain. Okay, so here any piezoelectric element cemented to the surface of the structure will be under stress. So that stress has to be determined by one particular structure, and that structure will be giving a strain. So whenever the structure is given by a strain, automatically the output will be recognized. From the formula you can obtain from it is like the output is obtained by using H coefficient given by V naught equal to H into ET. The fourth one is piezoelectric torque transducer. So piezoelectric torque transducer is nothing but you can see a cantilever present here. So this cantilever, what is the use of this cantilever is it will rotate like a small knob like a structure which rotates like this. So this can be used like a twister type and also like a bender type. Okay, so like a cantilever type bended biform can be used as a twister biform for the measurement of the torque. So a small movement can be done so that the torque, that is the movement, will be recognized from one part to another part, one distance to another distance. So this is piezoelectric torque transducer. And the fifth one is piezoelectric pressure transducer. So what happens here, you can see a spindle like a structure given, right? Just like a needle. And here the bender biforms is there and it has been covered by a diaphragm. Whenever we talk about pressure transducers, obviously you can be very sure that you will be having a diaphragm placed in it. Okay, so the diaphragm helps in controlling the pressure. So the sound pressure waves given here, with the help of the spindle, it just gives a pressure to this biforms and the output will be obtained. Okay, so the biforms diaphragm given here is to control the over pressure given by this as an input. Okay, so there is one range. So it will be always working in the range of 10 kilohertz normally. This is piezoelectric pressure transducer. I hope you understand all the 5 transducers. Thank you.